Hello students. So the purpose of this video is to introduce you about the Jefferson and the Websters method of apportionment. And you'll see on your screen, this is a continuation of my last video regarding the Hamilton method, because the two methods are very, very similar. Jefferson and Websters do not differ drastically. They're, again, very, very, very similar. And so I wanted to give you a chance to kind of think about the steps in comparison, meaning how does Hamilton look the same, and then in particular how does it differ in relation to the Jefferson method. So step one from Hamilton was to find your standard divisor, and you're going to find your standard divisor for Jefferson and the Webster's method as your step one. And so I've already found my standard divisor as 12, so nothing is going to change in this case. So I'm only going to erase the things I need to erase, and I'll write them in a different color other than that green so that you see where things are, shifting at. When you go ahead and get your standard divisor for step two, you're going to get the standard quota. So you see I have the SQ. We're going to keep our decimals in the Jefferson as well as the Webster's method. And so I have my 32 divided by 12, 80 divided by 12, and so on. I have all these values, and nothing is going to switch at this point, okay? Then you are going to write down your initial values for Jefferson. Now, here is where Jefferson and Webster's differ. For Jefferson's, you are not going to round. So, for example, with District 1, I would write that down as its initial value being 2. So, nothing has changed. In fact, all of these initial values are going to stay the same. So, everything in purple is exactly what you would get for the Jefferson method. However, with the Webster's method, you would round. So going in order, I would round 3, 7, 3, 6, 2. Okay? And then when you get those initial values down, you are going to compare that to the number of seats that you are trying to allocate. And this is where Jefferson and Webster's are a little weird. We're going to do this process called modified. So we're going to get rid of all this stuff because this isn't the process we're going to use anymore. Instead, we are going to identify what we call a modified divisor. So I'm going to do this in this gold color. You're literally going to pick a number. It's going to feel extremely, extremely weird because you're going to be like, is there any art to this? Is there any specific way I should go about this? No. You literally are going to play, come up with numbers, crunch, and solve. So I'm going to pick a modified divisor. I'm going to pick any value that I want. I'm going to choose 10.5. Again, I am going to admit I'm cheating a little bit because I know the number that is going to make this all work. But again, it's very likely that you may have to play and crunch, and that's okay. You might choose 11, and then you might go choose 10 and realize, okay, I need something in between. And so you may have to play around a few times. It's going to feel a little frustrating, but it's okay. On second thought, I'm thinking this yellow wasn't a great idea, so I'm going to switch to blue. I apologize. So I'm going to take that 10.5, and that is my new modified divisor. So I'm going to do the same process again, but this time I'm going to divide by 10.5. So I'm going to do each of my populations divided by the 10.5. You see that I am writing this out. Okay, awesome. And then I'm going to need to go through and actually do the division process. So 32 divided by 10.5 is equal to 3. Now again, remember I'm doing Jefferson's method. So I'm going to write my, my standard quota down, and I'm not going to round yet. But then when I write my initial value, I'm not going to round no matter what. So when I do 80 divided by 10.5, I get 7.62, but for my initial value, I'm going to keep that at 7. Again, if you're doing Webster's, you're going through the same exact process as we are right now, except that you would round the 7.62 to 8. That's the only difference. Okay, let's see, I got 3.90 here, so that's just 3. see, I got 67 divided by 10.5. That gets me about 6.38, so that's 6. And then 20 divided by 10.5 is 1.90, which is just 1. And I'm going to add up those values. So 3 plus 7 is 10, plus 3 is 13, plus 6 is 19, plus 1 is 20. And sure enough, this equals the number of seats that I need to allocate. Again, Webster's method works exactly the same way. So again, here we were doing Jefferson's, where all our steps stayed exactly the same until we needed to come up with a modified divisor, which is this 10.5. Again, there was no art to how we got 10.5. We literally pick a value and see what happens, and we may need to do that a few times. So again, it may feel weird and frustrating because there's no exact process that you're going through, but that's okay. You then take each population, divide it by that modified divisor that you came up with. If you're doing Jefferson's method, you're not rounding these initial values. You see, I'm drawing arrows. The only difference, if this was Websters, and I'll do this in this red color, if this was Websters, I would round. And so I would have these values that you see here in red, the 3, the 8, the 4, the 6, the 2. And I would actually find that I go over 20, and so I would need to come up with a new modified divisor, and I would keep doing that. That's for Websters. But again, if it's Jefferson's, I don't round those initial values. And that's it. I keep doing my modified divisor until I come up with the number of seats that I'm trying to allocate. So definitely a little less structured than the Hamilton method, but again, another option. As always, if you have questions or concerns, please don't hesitate to reach out, and have a wonderful rest of your day.